Oh, I think we're ready to start. All good. Cool. So thanks, everyone. Welcome to the 30th K8SUG Australia. If that wants to start. So, oh,
You said we were too quiet, right?
yeah, you were all too quiet. You need to make a bit of brouhaha. All right. Let me just, how do I? So before we start, just to do the acknowledgement of the country. So K8SUG Australia respectfully acknowledges the traditional land of the Kulin National people. We pay our respects for their elders past, present, and emerging. So we usually take some pictures during the night, or if you take any pictures and you want to share them, we have a QR code, a massive one on the screen. So if you want to scan this, it's a OneDrive box where you can drop all your pictures, and then we use them to publish them on the Meetup, I think, or you can just see all the pictures from there. So please refrain from deleting the other pictures. So like this, we can view them. So you can view all the pictures and download them all. So if you want to scan the QR code, and if you're done, I'm happy to move on. Tonight we have an agenda. So we're just going to do a bit of introduction on K8SUG, and then we have 2 talks on observability. So that's great. So today we will see everything about Kubernetes. So first we'll start is Baljeet, and then followed by Lasith. So I'll do a better introduction after. So the Kubernetes mission, we are passionate about Kubernetes and all the Kubernetes technology. And our mission is to accelerate the Kubernetes adoption in enterprise or for personal uses. So we do this by learning from each other and sharing the best practices. The meetup is run by a couple of volunteers. So tonight there's a few of them, just 3 of us here. It's the end of the year. I think everybody gets tired and we want to go on holiday and see Santa Claus. And few of them are abroad. So we have quite a few of us. So without them, I would not be able to run this. So I'd like to thank all the volunteers here tonight. And same, we would not be able to run those events without our sponsors. So our main sponsors are the Cloud Native Computing Foundation and Code Cloud, which is providing a couple of trainings. And for the events for today, so we would like to thank you, AWS, for providing the space, and SUSE for the food and the speakers as well. So K8SUG is started in September 2022 in Singapore, and since then has been growing up quite rapidly. So there's now Singapore, Australia, Canada, United Kingdom, Sydney, the Philippines, and coming soon there will be India. So yeah, there's about 20,000 members on the Meetup group. There's about 7 countries, so it's growing. It's a good community. There's a couple of events. So all the events that we're doing, they are all available online on the YouTube channel, or you can also sign in on the meetup.com. And there's a link, a Zoom meetup, so you can attend them from there. So the next ones are going to be on the 11th in Singapore, 18th in Sydney. The UK and Canada is to be confirmed probably later in the earlier next year. We usually have Yonkang, which is promoting the Kubestronaut, which is a certification program from the CNCF. So when you pass a certain number of certification, you get awarded the Kubestronaut, which gives you access to a blue jacket like this one, and you have a Credly badge that you show your expertise, and you have access to some dedicated Kubestronaut and private channel on Slack. And there's a bunch of other things, like you have 50% for the 5 certification that you can give to others. So we have a couple of Kubestronauts which have been kind enough to give away their 50%. And there's also 25% for the CNCF events, so 3 per year, which is quite convenient. So I think, how many of Kubestronauts do we have in that room? Ooh, there's 3 of you. That's good. So yeah, in Australia, we have about 21 of them. And 3 of them are available here free in this room. So that's great. I think it's growing rapidly. And
we got Cynthia on this as well.
he's not there. He's not on the list yet.
Cynthia's there. Yeah, next to me, number 4.
Ah, cool. So yeah, there's a bunch of Kubestronauts in Australia. Cool. Like we said, we can kind of keen on learning, and how you do this is by having access to things like KubeCloud, some of the certifications. So there's a bunch of code that you can use to do this. So if you want to take a picture, there's some of the promo code that you can use when you're ready to buy for your certification or your training. And there's also 50% off for the container security workshop. I have no idea when that is, if it's not passed already. Yeah, I think we had this last month, and I don't know when that is. So another code, check, but it might be already gone. So maybe for next one. So today's topic, it's all about observability and trying to understand what is running on Kubernetes. So the order is not right, so we just need to change the order. So Baljeet, you're going to be the first one to do your talk, if you're happy with this.
Yeah.
Yeah, no pressure. Awesome. So please give a huge round of applause for Baljeet. And do you have Zoom on your? Did you start Zoom?
I do,
Yeah. To go on z5.k8SUG. You don't need to sign in.
Oh, which one is that?
So if you go on the browser, open a tab and go on z5.k8SUG. SUG.com. That will redirect to the Meet.
Awesome.
Okay, so you need to unmute, and I need to mute. Yeah, all good. All right, over to you.
Thank you. Okay. First of all, thank you everyone for giving another opportunity to speak here. I was hoping to go second, to be honest, just on the build up back of the earlier one, but yeah, I think that's what it's gonna be like. So, today I'm just going to talk about not a particular tool set or anything like that. It's just more about the problem area and things we have been basically hearing from a lot of our engagements. And the question was more around, it's not about the tool to solve an observability problem. It's about the problem you want to discover. And I'll come to that in a second, right? So we started doing a research project within our team, but like I do not have $500,000 to go and buy one tool which can do this job. So I probably have to figure out and build it myself. Um, and I think we got some traction and deployed some of the what do you say, the POCs in some of the customers. But I thought I'll probably share it here as well around problems we are trying to solve and how with the landscape when we are talking about the containerized environment, your cloud native tech stack, and just SaaS platforms. Your each and every organization right now is sitting on an average of at least 80 SaaS platform they use to do a job, to get to point from A to B, right? And it could be your dev tools, your SaaS database providers and whatnot, and all those kind of things, right? So how do you go and solve the problem at scale, especially when you think from the cybersecurity perspective, right? So today is going to be mostly around the problem, the current state, and work to do. And my slide has gone once again. That's okay. I think it was my introduction slide, but I'm Baljeet. I'm a founder of Zig. We've been doing a lot of consulting work around the application security and the PAM space within Australia and now in Singapore as well. K8SUG, we built quite a bit of tools around Vault, Terraform, and all. I'm active open source contributor. Go and do some stuff when I get some time, or just try and build something when I need to. I think it's just my hands-on work is getting less day by day, because very quickly I'm realizing that once you get to one state, each and every job is a sales job, right? You can start an engineer, but you can become a VP of a company, and then suddenly you become a sales guy. So that's what I'm doing nowadays, but not here. So don't worry about it. Let's jump in. What you see here is what a typical enterprise looks like, right? You have your SaaS tools, CI/CD pipelines, your cloud providers, your database on-prem, all those kind of stuff. And then in a typical workflow, you're always using more than 3 to 4 of these tools to get one job done, right? What connects all these things together is something which I'm very close to, is around the identities, especially around the non-human identities. Human identities, as you know, Okta and likes have done incredible job to figure out what human identity looks like. How do you manage it? How do you manage it at scale? What anomaly looks like for these guys, right? And you have then two-factor authentication and all those kind of stuff in place, right? NHIs have nothing of that, right? There is no anomaly detection in NHIs unless you specifically go and build one. But for that, you need to know what the normal looks like. There is no two-factor authentication in NHIs. So, and most of these times, these are working in the backgrounds, right? You don't even know it exists. It's just doing some work for you. And 95% of the time, these are overprivileged identities. Overprivileged in the sense is, for example, if you use Zoom and when you try and, in your calendar, you create an invite and Zoom says, I want to access your calendar, can I create one? Without a second thought, we say, allow it and do it. How many of you have actually seen what all things Zoom can do on your calendar with that access? No one. All right, so one. So I think that's the reality, right? So, and that's where your security in this space comes in. So think about it in a second, that once that token or whatever authentication you have just given Zoom, somebody gets hold of it, they can actually get hold of your whole calendar and do whatever they want, right? This is a research done by IBM earlier this year, where a typical identity to non-human identity ratio is 45 times in each organization. So that means that if there is 1,000 people organization, you're sitting on around 45,000 non-human identities, which are working in the background to do some stuff, right? Great. Next thing IBM said is that the SaaS spend on cloud is going to reach $1.5 trillion by 2030. That essentially means the adoption of these SaaS tools is going to be massively increased, right? So the products which we are used to use on-prem, I'll talk about HashiCorp, right? So we built Terraform, we built Vault. It's on-prem, you can do whatever you want. But now they are selling HCP, cloud platform, the SaaS provider, right? So what is it causing in the current landscape, right? Just this year, there are around 10,000 of the confirmed breaches that happened, but somebody gets hand on some kind of NHI in the environment, costing $48 billion of loss already. And 30,000 of these breaches are under investigation at this point by the Cloud Security Alliance. So you can just imagine the number, the loss which is happening because of these identities that's got on somebody else's hand. And this is 84% of the breaches has happened this year is just because of exploiting these NHIs, right? And I didn't put a logo of the companies here, but it's not about like small companies or small organizations which are getting breached, right? One of the biggest software provider in the world and the cloud provider in the world got breached 2 months back, and 38 terabytes of data got leaked from their environment, right? The biggest identity provider got breached because somebody got hand on one of their NHI environment, dev environment, and all their support tickets, which they have interacted to with more than 100,000 customers across the world, got leaked. It's available on darknet right now. So all the tokens which customers might have shared with this identity provider are available over there, right? And the database service provider, SaaS database services, another one of them. So these are the organizations who have, which you would normally follow, that they are engineering culture, they're super intelligent people, and they are, with all due respect. But the thing is, there is the other side of it, which is there, which is the NHIs, which are almost invisible for the normal human eye, becoming the biggest threat vector in cybersecurity at this point. And this breaches are just increasing because of containerization of all these things together. And I'll come to that in a second, why it is that. There is a research firm, they did a honeypot analysis. So they deliberately leaked some of those AWS credentials in different ways, right? You would think that how does some credential can get leaked? Like I'm not gonna GitHub, I'm using GitHub scanning, I'm not gonna leak my credential. That's fine, great, you should do that. But there are other places, right? In an NPM package, they put a small AWS credential and it got breached in 40 seconds, the time they published it. 40 seconds. Think about the bots which are out there, which are actually scanning these things, which are out in the wild, right? Your web servers, your Docker Hub, if you by any chance have environment variable file or an image, and you created an image and you put it on Docker Hub, within 6 days, somebody gets hold of that security tokens. That could be your database credentials, that can be your anything else. They'll start doing whatever they want. Most of the times, Bitcoin mining. in your environment. So, and you won't even know about it, right? So this is all great. Coming to like what the state we are in right now. Like, let's say we are, oh, is there anybody here work as an incident response or in the SOC team? Anybody ever had done any incident analysis? Okay, yeah, that's good. At least one. So you think about like, you have a problem. You can see there is something got hacked or there is an anomaly which is detected. We are not sure what's the impact of it. We don't even know what really happened and since how long it's been happening, right? What is the thing which organizations do right now? Anybody knows this term, what OODA loop is? That's good. So this is a term developed by US Air Force guys when they are doing the combat training for their fighter pilots, right? It consists of observe, orient, decide, and act. What that means is that when they are training these pilots together, or if you are in a combat, whoever has done the OODA loop sooner is going to win the fight. That's how it works. This is what it looks like, right? So you have some observations, right? You orient your analysis around that observation. You decide what to do with that, and then you quickly act. But whatever you have acted on is probably not going to give you anything. It's probably something, like a false alert or whatever it is. You take that feedback, you go back to the observation, start doing this thing all over again. So what they do is they ask their fighter pilots in the jets to go in the air, turn their plane 180 degrees, like upside down, when the whole blood is running on your head and you're under immense pressure, do this OODA loop. Because whoever is going to do this quickly between the two jets is going to win the fight. And these are the people who then win in the protect their country. And I put this here because this is very, very close to what needs to happen into a security space. So once you find a smoking gun, how quickly you find what's going around that particular thing, act on it, take the feedback, go back, observe, act on it. This is where your whole company is basically residing on. Because as I showed you, there are bots out there just taking 40 seconds to, get hands on your energize, which got leaked. You have to be quicker if you want to protect your assets. The problem is, how does it work today? When we started talking to people, they said like, if I have to look at the current identities or something like that, main things just comes into the audit. Or they imposed everything on the manager. The poor manager, whoever is managing like 30, 40 people, they have to take responsibility about whatever is happening in their environment. And of course, there are petabytes of logs which are there, which you need to figure out where the smoking gun is or how exactly these things works together. The SOC is a security operations center. I have used it for example in this case. So what they do for one example is you have an AWS. You build a dashboards, multiple of these dashboards on Datadog or Splunk or wherever is possible, right? You probably might have some threat vector analysis done by your security team says, if this thing goes wrong, alert me, right? If this thing goes right, alert me, whatever it is, right? And what these alerts do is they create a Jira ticket for the SOC team, right? We were in one of the organization, very, very large organization in Australia. I met their SOC team. there were 30 of them here, 100 of them in India, and they have 4,000 Jira ticket backlogs, which they are observing. And I don't blame them for that. The problem is because you first of all need to know what you're searching for. You need to understand your workflows. And if you look at the SOC engineer doesn't know how your application, what all things application touches, right? Or they should know what are the index, for example, in Splunk World, what are the indexes which exist over there? What are the key variables I'm looking for? What are the keys I need to search for to be able to connect the dots? We had a chat before this, to be able to just say, this is what it is. It's not easy. And you multiply with the number of SaaS and cloud providers you have. It's incredibly hard. This is what they look like after, yeah, ChatGPT did a really good job over here, right? So we start thinking about it like, okay, what do we do with this, right? I mean, how do we solve this problem? This is where we are at this point. These are the different SaaS providers or cloud providers you have, right? How do we manage the identities at this point on these? You have secrets managers, you have password managers, you have SaaS providers managing their own tokens. Take the example of your GitHub tokens. Your cloud providers are also giving the secrets manager or just manage the key for you, right? And so on. As much as we say we have protected a secret sprawl, I would say we have brought down the secret sprawl, but that problem is not solved yet. Because a lot of secrets manager probably are not compatible with a lot of these SaaS providers. A lot of password managers are just a key value store. They don't do rotation or anything like that for you. SaaS providers, you create a GitHub pad token, it's going to stay there. When you do the development, I bet on this thing. Just correct me if I'm wrong. Who has created a GitHub pad token to work on his laptop and say this token should expire in next 6 hours because I'm done with my work?
Because I was checking GitHub secret scanning.
Yeah, you did that secret scan. Yeah. So
I don't want, because I was
exactly. So unless you have these kind of integration with even Vault, for example, it gives you that. But most of the time people say this secret 90 days, I'm just going to be on my laptop. I'm going to do my thing, right? So that's what. So we thought, all right, the first problem we need to solve in this case is bring all these things together. Because unless we bring all these things together, we cannot connect the dots, right? The second thing is we brought everything together. How do we connect these dots? So for example, if you have created an AWS secret token today, and it is spinning up something in your AWS environment, how will you tell what is the secret is actually doing in your environment? For example, if the secret has been created to, for example, spin up an EC2 instance on AWS, and suddenly the secret is also creating a security group, which is exposing your environment. How you figure it out? And you multiply with that enterprise scale, it's incredibly hard. There are tools CSPM tools who can help you do that, but you not need to have a lot of money for this. So you have to connect these dots together to be able to do anything. To achieve, once we build these connections, we can actually, I didn't put AI word here intentionally because it's always a buzzword, but actually it's a machine learning model which can learn from your knowledge graph, which is how your world is connected, and give you almost real time. I say almost because a lot of these things are not real time by design. For example, your CloudTrail logs and all those things, right? To analyze your security posture, to control that you have put in a procedures in place. Every company has said that, okay, all my secrets needs to be rotated in 7 days. can you say 100% this is happening in all your SaaS providers? It's incredibly hard to answer that question, right? One of my employees left the company. First thing I did is I killed his Okta account. But that employee also created 10 tokens in AWS while he was working here. Nobody knows it exists. Nobody knows what they are doing. And if I kill those tokens, is it going to bring down my production application? So what's missing is in our in current state is the context of these secrets, I would like to say. Context is essentially what normal looks like for these secrets. How do we detect the anomaly? And how can we quickly go through that OODA loop to provide that incident response in case something bad happened? So we developed a small POC for that, and I'll show that, give a demo of that in a second. So think about it in this way, right? You have a SaaS environment. Well, let's say in this case, a customer SaaS environment. You start polling the data or the metadata, not the secrets. Nobody's going to share your secrets, their secrets with you. You just need a metadata of these secrets. You build these connections together. You build the platform where your machine learning model runs. And what it will give you is real-time threat remediation, SOC dashboard control and governance, and dynamic policy allocation, right? Anybody aware of the term lateral movement in the environments, AWS? What does lateral movement means? So the lateral movement means that, for example, if you are an Okta user, you SSO into the AWS, for example. Now you got a role. Through this role, you assume another role, right? Or in this role, you spin up an EC2 instance. EC2 instance, you look at the instance profile, you grab the AWS role attached to that instance, and suddenly you become an administrator in the world of AWS. This is how complex these environments are. And think about that when you're looking at the Kubernetes scale of it, where tens of thousands of pods are running on the environment. Oops. So let's look at what it looks like right now. Very basic dashboard. It's not, as I said, like this is a research project we started doing a few things. So in this case, we have an Okta account, multiple of Okta users who get some policies to SSO into AWS, to assume some role, and then they can do multiple of these things together, right? Or they are doing few things. So what we want is to connect all these things together. How do we do that? The first thing you want to answer is, how many of these identities exist in my environment? The real identity, what is the source of truth looks like? So if somebody is using Secrets Manager to provision some identities in AWS, that's good. If somebody else is logging in and creating their own roles or something like that, somebody ran a CI/CD pipeline, which is now creating an identity or a role or doing anything about it, how do you get that? So there is a source of truth. That's first thing we solve, is give you the total number of secrets. And that's just not secrets of your AWS account IDs and all. It includes the secrets in your AWS Secrets Manager, right? The second thing you want to answer is, what all things these secrets are touching? What is my threat landscape looks like? You start looking at, it's running the Kubernetes pod and it has developing the AWS VPCs. There are policies associated with it. It has Kubernetes service, which is accessing those things, all this thing together. Okay, that doesn't give me much, right? So I know the number of secrets which exist. I know the things it is touching. The next thing I want to know is, are all these secrets are complying to my procedures or the SOC 2 compliance I'm sitting on, where I need to do these rotations and all those kind of stuff, right? So we start bringing all these secrets metadata into this very basic dashboard. It's just not about the access key. It gives you the data around when is this access key created, what is the status of that, are they rotated, when are they rotated, all those kind of stuff. And in case of the role, what are the different ARNs of these roles are, what are the policies attached to these roles, and all those kind of stuff, right? Great. So now I know that I have number of secrets, the things it touches. The third thing I have is what are the context of these secrets. Now what I can do with this is I have a role which I want to investigate, right? Or I got pulled in that find out what are the things this role can do in my environment, or are we breaching a compliance on these roles? So very quickly, just you can actually build this thing, a human, which is your Okta human account, who can assume an Okta role and can have an administrative access policy attached to it. And you can look at all the IDs and all those kind of stuff. It can read your CloudTrail logs and all those kind things together. But what is interesting is, what is the normal looks like for this? It's messy, I know, but this is what it is, looks like. So what is this policy doing? I've done in my environment so far. It gives you a sense of where the IP requests come from, who assumed this policy. The person assumed this policy has now spun up EC2 instances. You can actually say it also created a key pair to SSH into your EC2 instances now, right? What exactly they are using, how they're interacting. So it's through the AWS console. So you see how you start building a story around what the workflow looks like within my environment, right? The next thing is, can somebody, through this Okta role, can I assume another role, or can another role assume this Okta role because this has administrative access? How do you figure it out? So let's take a role, another role. So it starts building a relationship at the real time, that how these roles are connected together and what are the things they can actually do within your environment or are doing within your environment. So if you have to write a Splunk query for this, good luck with that. But within few minutes, when you're looking at think about from the SOC point of view, if you have a secret which got breached, the thing which is right now taking, and I'm not exaggerating on this, weeks to figure it out, is bring down to a matter of 2 minutes, where you know what the normal looks like, what are the things they have done, even if it has breached, what are the things it has done in my environment, so that I can go and solve the problem really quickly. Or if I go and revoke the secret today, what are the things which are going to impact it with this? Or how can a hacker can come into my environment and start making a lateral movement to get administrative like a policy access in the environment, right? So this was a very basic one, but then we start, okay, we are onto something, we are building, we are connecting all these things. What are the other things we can do? So if you look at the blue teams, in the security world, the blue teams are the teams which build protection for your cyber infrastructure, right? For them to build the protection around it, what they need to see is, what is my threat landscape looks like? Or how would a hacker will think when it starts coming into my environment? What are the different paths a hacker can take to get to, let's say, administrative access into my environment, right? So like in this case, how many of these roles, people, roles, or secrets have administrative access in my environment? Or they can actually assume an administrative policy within my environment. You could start bringing all these things together and say, okay, somebody has done something wrong. Nobody should have administrative access in my environment. I need to go and kill these things right away. For your Okta role, same thing. what are the things, who can assume it, what it can do, and all those things. So, and this is where a very interesting thing which came in one of our customer. They said, now we have this thing. One of the biggest problem we have is how do we protect our data from these identities? How do we know that somebody cannot do the lateral movement in my environment and able to access my finance S3 bucket? How organization protect their S3 bucket is through tagging right now. They do hundreds of tags, like this is the finance, this needs to be there, and all those kind of stuff. And then you have different security group encryption and all those kind of things. But security encryption will not work if somebody is already in your console. You need to develop the visibility. How do you protect it, right? So we have this case where say I am a public listed company. If somebody gets hold of that S3 bucket, I'm done. My business is done. I have to shut down the doors. How can I figure out what are the different identities which exist in my environment who can potentially assume different roles and able to access the bucket, which I don't want them to access? So you can actually just say, this is my S3 bucket, and it gives you all the identities which exist. This is my test, so I put a lot of things over there. And it gives you that what are the roles can read and write into these buckets. So when you tackle the problem of misconfiguration into your environment, that's what it helps protect. Misconfiguration happens all the time. But that misconfiguration can be very, very, very expensive for the companies at the verge of shutdown, right? So you can actually build these things together. I'll not go much into these details, but we started looking at the Kubernetes kind of workloads as well. Now that you have a kube namespace and you want to know what all things exist in that particular namespace, secrets and all, right? And what are the services which are exposed through that particular plugin, agentless, within probably 30 seconds, you will have a bird-eye view of what's happening in your environment. It's not just that. When you look at the namespace segregation, you want to see, well, are there any other namespace somehow able to assume a service account which can get into another namespace? So you can actually just look at the build both of these namespace together, and it starts giving you what are the secrets which exist or the service account exists, and it can virtually assume the role and gets you the point of unit. One of the things which came out of this is, okay, this is all great. It's a dashboard. It doesn't give me anything. What is the value analysis I do onto this? Think about from the SOC perspective, the person who recently joined, right? So SOC engineer started looking at the Jira tickets, have no idea how the Splunk or at least the indexes currently exist into your environment and all those kind of stuff. How can you enable them to solve the problem, that OODA problem, to be able to quickly turn around and protect what is now breached? So we used LLMs on that. So what we did is I created a video for this because in my attempt to connect LangChain with Claude, I messed up a lot of things. So when you look at the LLMs as a chatbot for a SOC engineer, you can actually look for, okay, I have a key owner, I have a key ID, I want to know more about this key ID, right? And you can actually just go list all the details of these key ID, this particular key, which I feel suspicious, right? And it looks at your knowledge graph and it says, start building the data around it that, okay, this is owned by this user, requested by this, created on this, rotated on this, and last used by GitLab in our environment. This is where it exists. I'm like, okay, this test user 4 looks very suspicious to me. I want to know more about this guy because there might be more things he has created. I want to know everything about it. So this key is owned by test user 4, and it just go into the environment and say, okay, these are the 2 keys he has owned. And now you can quickly go in, what is the context of these keys looks like, so that I know what is the threat, what are the things this key has potentially touched, so that I can go and remediate that problem very, very quickly. So for the SOC engineer who was actually spending weeks to get this solution or get this data in, through these knowledge graphs, you can actually bring down this time to minutes. What I like to say on this one is basically these all things are normally invisible. You can create hundreds of dashboards, but in reality, it's incredibly hard to actually monitor these dashboards or do anything out of it, unless you intentionally go and figure it out. So this is where we are at this point. What we are building on top of it is a very interesting problem somebody told us is, can you figure out, what if somebody can run a CI/CD pipeline or a GitHub action or just as an infrastructure of a code, because everybody likes it, just run one code line and can go and assume the administrative access into your environment. The reality is a lot of recent hacks are happening just because of this thing. We think that this is the developer, he can just commit the changes and nothing will happen, but one line in that IAC can expose all your whole AWS environment to the whole world. So that's a problem we are trying to solve. Next, it's achievable, it's really complex, but yeah, I thought I'll just come in and I'll probably just stop here and happy to take questions, but yeah, I just wanted to share this research projects which we are working on, which you can think of multiple tools which are existing in an environment work together to get the solution. But as we all are practitioners here, I would really encourage we can actually build it on our own. I'm not, we are thinking about at some point go and open sources, but it has to go to some maturity level before we get to that particular point. So that's all I have. Happy to take any questions. By the way, when you look at you might think how this whole thing is working is through the graph database. So this is how we connect all these things together into your environment through Okta, through AWS, through your network policies, and all those kind of stuff. And then on top of this is what we build is the solution for you. That's all I have. I think I'm done. I probably am over time, so thank you for that. Happy to take questions if there's any. I'll just, yeah, go on.
Is this something that the identity providers have looked at themselves? I mean, obviously, some of them they're trying to do a lot of complex stuff, and it's pretty easy for their customers to mess things up. You know, like you said, I mean, you'd think that should probably be something that they've got.
Yeah, that's a really good question. The answer is yes and no. Why I say yes and no is because think about Okta, for example. Okta will not care about what's happening in your AWS environment, right? It can just tell you who can become what in your AWS environment. That's it. What they are doing into your AWS environment, they don't care. AWS will not care about is this identity has been leaked, because when you look at the NHIs, it does not have a MFA. So whoever have the access of that NHI can become a person, and AWS will just respond in the same way, right? So the problem is that you can look at the Okta logs and see who all logged in and did what, or basically SSO'd into what. But The problem we have is we just want to see, anybody can tell you who logged in at what time, but what they are actually doing, what's the normal behavior looks like for these identities, that's incredibly tough, because that's where you have to just go into another SaaS provider and look at their own, like for example, in this case, CloudTrail log to figure out what they are actually doing. And then you have to connect these things together. So that is where I think it gets really complex. And AWS, think about the multi-cloud environment. AWS can tell you, this is my dashboard, do it, but they won't care what's happening in your GCP environment or your Azure environment or your on-prem environment. Even if you look at the AWS sites, they would,
Before we move on, we forgot the previous QR code wasn't working. You probably noticed, or you probably tried and it didn't work. So that's why there hasn't been any photo deleted. Oh, you're really good. Either way, that's great. Here is the updated one. Cool. And we know when that is. It's on the 12th of December. So you still have time if you wanna join. Cool. That was the two correction we wanted to make. So please welcome Lasith, which is again talking about observability, but this time more for Kubernetes. Please welcome Lasith.
All right. Good evening, everyone. For those who are seeing me, hearing me for the first time, I'm Lasith Haturusinha, solution architect at SUSE. I've been with SUSE for more than 5 years now. So happy to be here, presenting again. Like last time I spoke about new vector or SUSE security. This time I'm going to talk about SUSE observability. Right. So with that, let's see. Okay. Okay, cool. All right. So let's start with Kubernetes, right? What do we do with Kubernetes? Kubernetes helps us to manage clusters, your containers, your pods, right? In the simplest form, right? There's a lot of things that happen in the background with Kubernetes. You don't see some of the things that's happening in the background because it does a lot of work in the background. And managing a single cluster or a couple of containers and managing them is quite simple or can be manageable. But if you have multiple clusters, different environments, it's quite hard, and it gets, as your environment grows, it becomes complex, right? So as the Kubernetes landscapes evolve, grow, they become enterprise, right? You start with a test environment or POC, and gradually it becomes your production landscape, and then you build your dev environment. You guys know about these things, how it's been evolved in your corporate environment. And these landscapes become mature, right? As it matures, you need to be consistent. Your operations need to be secure at scale, right? You need to off-ramp if you are using your traditional applications. You want to move from VMs to a container, a platform, or managed by Kubernetes, right? And then, of course, you need to have some insights and visibility around your applications, right? So these things matters to all of us. Now, with that, the topic for today is observability, or SUSE observability. What do you mean by observability? The observability means the ability to measure the internal states of systems by examining its outputs. Now, when you talk about internal states, your internal states can be health and performance, right? And how do we, sort of come to these metrics? We examine the outputs. So the outputs can be your metrics, traces, and logs. Just have to wait for the transition to happen. So basically, outputs are the metrics, traces, and logs, right? Now, we take this information on your Kubernetes cluster. So massive environment, right? You've got different landscapes, different environments. All this data is produced from your environment, your Kubernetes environments. And what we do is we put it into dashboard, right? We look at these dashboards. So organizations will have different dashboards to have your insights. Your dev team will want to understand, your production teams will not want to understand the performance of your application. So they'll have different other tools. You bring information into a dashboard. Now, does this help? When something happens, does this help you to troubleshoot? Looking at these dashboards, right? It just gives a bit of information why there are error spikes and why there are services getting 20% less traffic than yesterday, different questions. But does it really help you to troubleshoot? Yes, data has value, but it's valuable, but it's not valuable, right? The goal of observability is not just collecting data, but ability to derive actionable insights, right? So with that, SUSE observability gives you that capability. SUSE observability helps you to more than just metrics, logs, and traces. It helps you to understand the context and to do the necessary troubleshooting. So, for example, there can be certain changes at the pod level or the application level or at the service level. Certain changes happen over time, right? And you need to know when these things happen and why it happened, what's causing these things. And you need to understand the relationship with different other resources. Maybe these applications are spread across different other clusters, right? And different environments, landscapes. So you need to understand the topology of that. And you need to understand about the events and the security aspect as well, right? Now, with that, as I said, different teams will need to know different information, different inside information. Your platform team wants to understand how the cluster is operating. Your dev team wants to understand how the services and resources are happening, like are there any issues, whether they need to troubleshoot. And as you go up, you can see the product owners, the network operations center, the business owners, some people that we always forget about. We need to know how their business is operating. If something is impacting, it can be like a small thing, but it's impacting their business, right? They want to make sure that they can improve and bring reliability for their business. So should be able to connect all organization layers to improve business reliability. And that's what SUSE observability does. Now, this sort of pyramid talks about how data being collected, refined, and moved into actionable level, right? You collect the raw telemetry data, right, from various sources, and then you put it into a topology view, right? One of the key aspects or uniqueness of SUSE observability is to go time travel, right? To go into the past and see, all right, there are certain things that happens in my application, my component or my services that keeps on going down and coming up. I don't know what's going on. I want to go and see at the one or in that second as to why it happens every time or in certain cases, right? And you should be able to see them in a topology view that gives more information and sort of relationship among other resources, right? With the topology, you have the correlation, and then as you refine those information, you do the issue recognition, right? So you find, okay, these are the issues, the certain components of services that's been causing, and these are, you identify the issues. And then you want to go down into remediation, right? Most of the observability tools will give you report your issues, but you should be able to understand how to remediate them and actually go into the resolution, right? That's the complete full stack of an observability tool. With SUSE observability, as I said, certain most of the observability tools that we come across will have reporting a problem. But SUSE Observability goes beyond that, gives in you from triage to examine, diagnose, test, treat, and cure level. So it helps you to resolve the problem and bring your application or your environment into a healthy system. I thought of adding this slide as well, some of the unique approach to troubleshooting, making data accessible, easy navigation, guidance of diagnosis and remediation. But generally what I'm trying to say is the SUSE Observability gives you a single tool in a timely fashion where you can time travel and understand where things are going on wrong and how can you remediate. There are out-of-box 36 plus dashboards, remediation guides, best practices that's been inbuilt into SUSE Observability, right? For anyone who wants to, from any level, from any personas that I spoke about. It doesn't have to be just the platform team, or it just doesn't have to be just the dev teams, but every persona that I spoke about in the previous slides can go in and understand, right, what's really going on? How can I improve my application? How can I improve my business with this? So no more switching between tools. I mean, look, these are great tools. There's nothing to say anything bad about them. They are great tools. It's just that we have to sort of move between different tools to understand where things are, right? You want a one single environment, right? The problem is when you have all this data and these data being accessed in different tools, it takes time to resolve your issues, right? If you have everything in one single place, in one single dashboard, you can just click and go through and go down to the lowest level and identify what's really causing. That's what you need. So look, if you already have these tools in your environment and they are on production, you've been running for years, that's fine. You can have SUSE Observability as well. That gives more approach to resolving your issues in your environment. So with that, I just want to bring this slide because we are doing a little bit of rebranding of SUSE. I thought of bringing this up because we were all, most of our SUSE people were away for the last 2 weeks. And I'm recovering from my jet lag. So we have done some rebranding. So some of the names that you'll come across, like Harvester, is replaced by SUSE Virtualization, right? Longhorn is replaced by SUSE Storage. New Vector, I mean, I said New Vector last time, but I won't be able to say New Vector anymore because it'll be SUSE Security. Likewise, we have renamed all these components as part of SUSE Rancher Prime. So SUSE Rancher Prime is an enterprise offering for those who doesn't know about it. SUSE Rancher is just the community version. And for Rancher Prime customers or enterprise customers of SUSE will have access to SUSE Observability as part of their solution, part of their offering, right? At a zero cost, right? But anybody who is running Rancher community who wants to look at SUSE Observability, I'll just give a quick sneak peek on what that observability dashboard looks like. We are bringing what we call SUSE Cloud Observability Cloud or SUSE Observability SaaS offering. Right, it's a SaaS offering. We just launched it with during AWS reInvent this week, so is available in the marketplace as well. So the whole stack is there with the SUSE Rancher Prime, and of course we are a leader in the Gartner quadrant, right? So this happened even before we acquired the SUSE Observability, or previously known as TechState. Before we acquired. So we are now at the Gartner leader quadrant and the media as well. So with that, just gonna click these ones quickly. So, all right. So the whole complete stack, yes, they're all based on open source solution. The reason I'm talking about all these solutions, yes, it's an enterprise solution, but they're all based on open source solutions. With that, let me jump into a quick demo guys, about, I believe that,
Can you go to the last slide? Was that's really important.
yeah, sure. As I jump into the a quick demo, any question? Does it make sense, the value of SUSE observability? How many of you are using observability tools in your environment? Like,
It makes a lot of sense. It's used like out of contained sites.
sorry,
Out of contained sites from just with Kafka around.
right?
Just
Different tools. Okay, cool. So a few other.
So Kubernetes is nothing without application. Applications are first class citizens of Kubernetes.
Yeah, absolutely.
And if you don't have application observability, you are in a dark well.
Yes.
You don't know how your applications are behaving.
The golden states.
Exactly. So I think then observability is the key to know how the applications are behaving at the moment.
At that given point of time. Yeah.
Exactly. They help a lot troubleshoot, to identify the bottlenecks, which if identified in time, can help you, kind of save anything and everything.
Yeah, makes sense.
That's how it goes.
Yeah. Thank you. Yep. So I'm glad this was useful. Yeah.
So you are using open telemetry in your observability.
We use
Yes.
open telemetry as well.
As well, or it's basically based on the open.
We use eBPF to gather all the information. We also have open telemetry. We can also integrate with any other like Splunk or any other tools as well. Even can do the cost optimization as well. Those are these are not out of the box. These are customization sort of work. Yeah.
One more question. What was, I understand that you put the name when you said that you acquired a company with which you got into observability. What was that?
Stack State.
Stack
State.
State.
Yes. Yeah. That's now part of SUSE. We acquired last year. I mean, sorry, this year. Yeah, even though we started our new financial year at SUSE. But yeah. All right. So with that, let me see if I can bring this quickly. I want to do a deep dive. I'm not a observability guy, but I'm trying to explain some of the things so that you can understand what it looks like. So can everyone see, or do I need to zoom in? Let's see if I can zoom in. Yeah, okay, cool. All right, so generally, so I have sort of reset everything. So all clusters are selected here, but I've selected one single namespace. You can select multiple namespace if you want to, right? This is the general view, right? This is the dashboard view that we will all come across, which gives you the golden states and all the information of various resources and components of your cluster, right? And SUSE, so observability can also go into different Kubernetes, like at the service level or the deployment level, pod level, configure. You get it, right? We can do all at different levels. So if I just go back, and this is the key part of SUSE observability, is to give the whole topology view, right? At the bottom, you can see sort of a timeline at the bottom, right? So you have like a topology interval. So you can say, all right, give me the topology during this interval, right? And it will bring it up at that. For example, if I just, here's my mouse. Okay, found it. Yep. So for example, if I just, you can see it goes into the seconds and it gets updated. So each and every level, it goes in and shows you where things are, right? So you can do visualization settings by domains, just include direct relationships. You can see 3 different clusters in here. You can see some colors in here. Generally, red means critical, broken, you need to do something. Yellow means orange, means attention, there's something going on, deviating. Green means on healthy and it's all good. You don't have to worry about it. So general hello. And so for example, if I just, let me just have to, yep. So for example, if I click on one of these, you can see how that relationship with that group. So the groups are on a circle, individual components are on a square. So if I just click on this, you can see health is deviating some information. But if you want to go into the component view, this will bring it up with all the other information on that service catalog, right? So there are monitors, right, or parameters that you set to monitor the health of the service. You can see out of the three, one is unhealthy. So for example, if you want to look at why it's unhealthy, you can just go in. It'll bring up some information about that monitoring of the parameter and gives you how that particular monitor or particular component or a parameter behaving during a period of time, right? And then as you move down, there's a bit more information, and then you have a remediation guide, right? So if I go up again quickly, it says, there's a problem with the error ratio, right? And gives you a description. For somebody like me who has no clue what this is, I'll probably read, okay, all right, okay, let me move on to the next step, right? So how do I, what are the possible causes, right? It will give you the possible causes, right? And tells you how you can remediate them, right? Yeah.
Is this by itself, or that someone had to tell it, okay, if this issue occurs, this will be the remediation, or is it by the platform?
By the platform.
By the platform.
Yeah.
So
So these are,
or you have also deployed it.
yeah, so we have taken some of the information, like industry best practices, incorporated into the SUSE observability, and that's how it's been generated. Yeah. Okay.
No, but that's static, or if you learn, like, let's say, an operator or operation guy will see this and perhaps he will fix this issue, maybe a little different way than what is depicted here. So next time when it will come, I mean, self-learn in a way?
Not self-learn, not self-learn, not self-learn. These are
like
the rule-based. So basically, let's say if something like this happens, what are the possible causes for this to happen, right? And best practices, how you can resolve them based on the best practice guides, and that's how been generated. There can be certain scenarios where your metrics are different and you want to build something complete. Those are external, but out of the box, there are certain things you can use it for your Kubernetes environment. So like I said, possible causes and how can be, so it gives you a lot of information, and you can see based on at different times, you can see where things are. You can look at the events, for example, what alerts been occurring, right? And you can also see the related resources in here, the pods related to this service or any other related services of this particular component. As you go down, some of the golden state information in here as well. A lot of information in here, so you can go into detail. So for example, if there are any changes that has happened, you can look at the changes, you can see configuration change has happened for this container. And you can go in to see what changes that happen. For example, you can bring it up and see, all right, so at this, previously it was at this stage, and now at this stage, these are the changes had happened. It can be just an update in your, you probably build a new image, a new container with a new image, and that can be the reason it's causing these issues. So likewise, you can go down that path. Yeah. So if you want to go into detail, you can just click in here and it'll bring up, all right, these are the related services, right? So the front end, the catalog DB, And then you can go into those as well. For example, let's say if I have a problem with the front end, you can go in. All right, I can see more information here, right? These are different metrics in here, right? And you can, let's say, for example, the pod looks healthy, so I don't have to really worry about, but if I go into pod level, I can go into the pod level as well.
So is there an agent running inside the cluster?
No, they're all information pulled out from eBPF. So no agent. At this moment, no logs, but generally there, because of the time frame, if you have any logs, you can even look at logs from the dashboard itself. Yeah.
I worked with a few of these tools before. Generally, they are agent-based. So what we do is we deploy collector agents inside Kubernetes cluster, and then those agents, they report data into a dashboard, and then that's how you visualize that, right?
Yeah. Yeah.
I understand that with eBPF, I mean, it's been quite a lot of discussion that let's switch to eBPF rather than deploying agents individually on the cluster, because eBPF is a part of Linux itself, right? So just to know more on it, it's like an agentless thing, and whatever, because Kubernetes is deployed, let's say if it's deployed on a Linux operating system, it's gonna use the operating system eBPF to calculate or gather metrics and other things, and then it's gonna
push it into the observability server or the master.
Right.
Yeah.
Right.
Yeah.
So that's totally agentless.
Yes.
So the eBPF is basically an agent. It's not magic. It's got a.
Yeah,
It's
I mean,
still, yeah, it
It
still
it
comes
really
from
works, but
stack.
not as if you are installing it manually on Kubernetes or in different namespaces. That's it.
Yeah. Yeah.
How do you correlate things, like for example?
So that's the beauty of SUSE Observer. So all the background stack state. So what they have done is they managed to build everything and put it on a stack graph. There are a lot of architecture that has gone into the system that brings everything to correlate. So it's not just, hey, I pull these logs and information and it sits there and you view them. That's why the uniqueness of this observability tool is it correlates, builds all relationship maps of each other and then builds the whole topology. So that's kind of a capability that's bringing up through SUSE Observability or in background stack state. So,
but it's only available of SUSE on AWS or in other environments as well.
so this, I mean, look, you can run on any you can manage any downstream. It doesn't have to be on Rancher, RK2 or anything like that. But SUSE Observability is available with Rancher Prime. So the enterprise customers of SUSE, they'll have access to this free of cost. So they don't have to invest or pay or buy any observability tools. I mean, if they have, that's fine. You'll have another tool that gives more visualization and insight to your downstream clusters. But if somebody is using a community-based version or any other version, you can use a stripped-down version of this, which is called the SaaS model of the observability tool. It's a paid, like a minimum few clusters, like you can see and understand what it looks like, but doesn't, yeah, it's a stripped down version.
Got any query language to kind of create custom queries to fetch custom data?
You can, but I have no answer to that, but I know you can. Yes.
Does it integrate well with the external tools like PagerDuty?
Yeah. As I said, out of the box, you can just deploy the Helm chart on your downstream cluster so that it will pull all the information to the master, the observability dashboard. But if you want to integrate with external tools or do custom optimization, which even I have to figure out how to do this is a new tool for us as well, which you can do as well. So yeah.
And we can deploy it on-prem as well.
Anyway, so your downstream clusters can be on-prem, on cloud. As you can see, this particular cluster that I'm looking at is on GKE. So information pulls from GKE, RK2, everything. And if you like, for example, you have an application that's distributed across multiple clusters, which are set up in different environments. Yeah. With that, it's quite a simple demo. I mean, look, I'm not an expert on observability, but I just want to show you what the observability tool looks like. Yeah, I spoke about on slides. Hey, what does it look like in real? So with that, thank you for all the comments, feedback, questions, and I hope this was valuable. Thank you, guys.
Cool. All right, so that was the end for the presentation, but there's more. Ah, crap. We start again. Hello. Yeah. So we cannot run without these three things. So speakers, volunteers, and sponsors. For the volunteers, we're pretty full at the moment. But if you are interested in speaking, please feel free to scan the QR code and just submit a talk, and then you might have a chance to present. Like Baljeet did today. He submitted a talk, what, a week ago or a few days ago. And yeah, we had a free space because everybody else was on holiday somehow. So yeah, you can have a chance, and you see it's a small committee. It's quite welcoming, so it's a safe environment. If you're new and it's your first speech or first presentation, and it's usually needs to be can go from very beginner thing, because we are not all at the same level. We are not all Kubestronauts certified and everything. So there's multiple levels, so you can present things. Your journey is always interesting. And the other thing is we cannot run without any sponsors. So again, thank you for SUSE and for AWS for today. But if you have a company and is willing to sponsor for the drinks or for the things, scan the QR code and submit your thing. We are available everywhere on all social media. So if you want to follow us, feel free to scan the QR code. Okay, and on to the prices. So there's usually a lot of things. Oh, and I think I'm the one who forgot to bring the bag with the. There's a lot more things in my house that I'm not going to use. But we have a beautiful Rancher t-shirt.
It's large, so.
It's a large one, but so suits everyone. You don't need to be fashionable when you wear that. So that's the statement. So we have 3 SUSE plushes. If you haven't seen, is it the big ones?
Yeah.
So if you haven't seen them, they're quite high in demand. We have 3. They're not there. So we'll need to get your address if that's what you want. And we have 3 code cloud access for 6 months and 50% off for the Kubernetes exam. So how we do this, for those who haven't been there, we usually run a quiz. And so there's usually 10 questions. The correct answers, and the faster you answer the answer, makes you win the prize. So there's a leaderboard. So latency is key. So you're probably better off having a good Wi-Fi and be on the Wi-Fi. And if it doesn't work, the thing is guess Wi-Fi, and the code is the password is there. So it's broken wires at 2019. And the funny thing is it works even in the UK. Same password everywhere. All right, so we will see if we manage to do this. Ready? Start the quiz.
Do you have the,
No, sorry, how to reach the quiz page?
It's coming if we have access. Yeah, there you go. So how you do it, you scan the QR code, you will see the questions on your screen with usually between 3 and 4 answers. So it's multiple questions, multiple answers, and there's a correct one each time. So please register. I like how this tool is working. Okay, are we all ready? All good? Or does anyone need more time to fill in?
We got the plan.
Yeah, I think we're good. All right, so get ready. We're starting the quiz. And the first question is in 5, 4, 3, 2, 1. The goal of observability is only about collecting data. No, I don't have the... Is it going blank for everyone?
I mean, it doesn't feel like too long.
Okay. Next question. So no, you can't skip the question. So gives every time 30 seconds for people to answer. Okay. Next question. Which organization layers, personas benefit from SUSE observability? And the correct answer was all of the above. So everyone benefit from good observability. SUSE observability is part of SUSE Rancher Prime, yes or no? And the correct answer was yes. Everybody got it right. That's good. SUSE observability provide and view.
Yeah, I fill in the blanks.
Yes, first time of, it's a good one. And the correct answer was travel time, ability, and topology views. Okay. Question 5. What is the recommended best practice for managing permission for non-human identities in AWS to adhere to the principle of least privileges? Oh boy. We might need more than 30 seconds. That's good. So the correct answer was to use IAM roles with narrowly scope permission specific to the task required. Question number 6. In Kubernetes, which method is considered most secure for a pod to assume an AWS IAM role? So using Kubernetes service accounts. And whoever wrote the questions didn't attend the talk because we didn't see any of these things. But that's good, everybody got it right. Oh, most of you got it right. Which AWS service helps detect and reduce unused permission in IAM policies for non-human identities? I would have flipped a coin similar to you and just have once, yeah, not much chance. Two more, and I think we're good. In Kubernetes, what is the main security advantage of using rollback access control, RBAC, with tightly scoped roles for non-human identities? The correct answer was to minimize the impact of a compromised service. And the last question. According to recent best practices, which approach should be avoided to prevent security vulnerability when handling non-human identities in Kubernetes clusters? The correct answer was granting cluster role. So yeah, that was a negate. What should be avoided, not what should we be doing. There you go. Yes. All right, so let's end the quiz and see who is in the first place. And tonight, our first winner is Adam. Where is Adam? Hi, Adam. Congratulations. What would you like?
What are the options again?
So we have, yeah, Code Cloud 6 months.
Yeah,
Oops.
Code Cloud.
Please say, I don't know.
Yeah, mine just ran out. So
Yeah?
yeah, sounds good.
Code Cloud?
Yep.
Awesome. So if you can give your name to right,
Just email.
Yeah. email and name, and we need also the LinkedIn profile.
I will, yeah.
Yeah.
I can email you that one.
In the email, I'll just.
Where is Mark? Because we need someone to take a picture as well. Yeah. Just hold on.
Oh yeah, sorry. Yeah, cool.
Well done.
Nice, I'll take it one thumbs up.
Thank you. Next, we have Kanav. Where is Kanav? Hey, congratulations, Kanav. What are you after?
Is it 6 months? Is it 3 months?
6 months. 6 months.
And is it like 6 months of code access?
It's a training platform,
Yes,
so
that's
specialized for.
labs. You can just practice, that like this year and all those things.
All right,
Yeah.
makes sense here.
Awesome.
Once again.
Thank you. Congratulations. If you can, yeah. Next, we have David. Congratulations, David. What are you after?
There's a flash will be good, I think.
This is a plush. Okay. So you'll need to give your. Oh,
I need to get your home address because it will be shipped. Thank you.
and we need to let's take a picture.
Yeah. So, then it's the detailed ones, like this. Just write your,
Okay, in fourth place, Bastab. Congratulations. A code card access? Good, awesome. Thank you.
I thought you were gonna do 3.
No, we're going to do 6 tonight.
6.
6, yeah.
I should be getting point. I missed one question. Oh, I'll stay actually.
Okay, thank you. Victor, where is Victor? Congratulations, Victor. So what would you like? There's also a nice t-shirt.
Maybe just a code, I don't know.
A code cloud
No,
or
the,
50% off?
yeah.
Yeah.
Or the code cloud, is it?
I think we run out on the code cloud. Yeah, that's the third.
Just the
A
code.
code.
Yeah.
Code.
send me the address. Okay, you're the first, right?
Thank you. You'll need to give your.
You have a email address.
And no, the 50% off. And Jiang, congratulations. What are you after? Hmm? The t-shirt? Awesome.
I need to be a walking promo, right?
Awesome.
I need to be a walking promo.
Let her get the right hand, let her go.
He's having that, he's having.
Okay, we're going to stop at, because we run out of the, yeah, I didn't bring the bag with all the small goodies. So we're running out. So we're going to stop at the number 6 for today. And yeah, so thanks everyone. So there's two more things to do. We always are keen on having some feedback. So we value your input. So if you would like to give us a bit of feedback, so there's a form, and after that we usually take a picture at the front of this. So a group photo with everyone.
That's fine. Just send me let's say
Yeah, let's do the group photo. You can all come at the front.
Okay.
That's yours.
Why you just said get me plus or something like that? That's probably
Hey. I'll take the picture.
Okay, yeah, sure.
You are the first one. To take picture with the first one.
Within a bit more.
You got an iPhone?
I don't want to go and just make you fats and fats. All right, so all of you say Kubernetes.
Kubernetes.
One more. It's gonna be 50 now. Cheers, everyone. Cheers. Cheers. Thank you. Good meeting you. Good meeting you. So you guys know? No.
See you. So,
See you next time.